Every prompt you send to ChatGPT, Claude, or Gemini runs on someone else's GPUs. Your data, your code, your company's secrets, all flowing through infrastructure you do not control. For most people, that is fine. But if you are in healthcare, finance, government, or anywhere that compliance actually matters, fine is not good enough. Running AI models on your own infrastructure sounds straightforward. It is not. GPUs are brutally expensive. Get the setup wrong and you burn hundreds of thousands of dollars on mistakes. Get it right and you have inference as a service that any team in your company can use, with your data never leaving your network. Let me be clear about something first. For most use cases, it is cheaper to just call an API. Use OpenAI, use Anthropic. GPUs in hyperscalers are expensive. The technology changes fast. But there are real reasons to self-host. Your company policies require it. Regulations demand data never leaves your environment. Your scale makes self-hosting cheaper than per-token pricing. You need low latency without network round trips. You have fine-tuned models that are your intellectual property. Or you're simply tired of rate limits. If you want to run a model yourself, you need open-weight models. And right now, China dominates. Alibaba's Qwen is the most downloaded model on Hugging Face. DeepSeek shook the industry. Chinese open-weight models now account for roughly 30% of global AI usage, up from 1% in late 2024. Can you trust them? Not blindly. Security researchers found DeepSeek complied with 100% of malicious requests using common jailbreaking techniques. 100%, compared to 5 to 12% for US models. Self-hosting eliminates the data exposure risk. Your prompts stay on your servers. So, where do you run self-hosted inference? There is only one reasonable answer. Kubernetes with GPU nodes. Inference needs GPU scheduling, and Kubernetes has first-class support through the Nvidia GPU operator and node feature discovery. You get declarative GPU management, autoscaling based on utilization, multi-tenancy with namespaces and resource quotas, portability across EKS, GKE, AKS, or on-premises. The entire inference ecosystem, Nvidia GPU operator, vLLM, everything is built for Kubernetes. Here is how we build it. A control plane cluster runs Crossplane with custom API definitions. When someone applies a cluster resource, Crossplane provisions a Kubernetes cluster with CPU and GPU node groups, installs the Nvidia operators, deploys vLLM, wires everything together. Users do not see any of that complexity. They fill in a few fields. Pick a provider, set a node size, enable GPUs, choose which apps to install. That is all. When someone needs a model, they apply a single custom resource, specify which model, how many GPUs, the ingress host. Crossplane creates the vLLM runtime, the service, and the ingress route. The model gets pulled, loaded into GPU memory, and starts serving. vLLM exposes an OpenAI-compatible API out of the box. Any tool, any SDK, any code that works with OpenAI works with this. Point cursor at it. Hook up your agents. Build custom applications, standard API. Everything works. I deploy infrastructure under air raid sirens. I manage 62 Azure subscriptions across multiple tenants. When I say infrastructure matters, I mean it literally keeps things running when everything else falls apart. Self-hosted inference is not just about saving money or avoiding rate limits. It is about control. Your data on your hardware behind your firewall. What we built today is the minimum viable version. Production needs disaggregated inference, KV cache routing, gateway API, autoscaling, multi-cluster patterns. That complexity is exactly why cross-plane compositions become essential. Build the platform once, expose simple APIs. Let every team deploy models without understanding the infrastructure underneath. Your data, your GPUs, your rules. DevOpsDive.com